Before we see if we have any perfect square factors, let's multiply these together. So we're going to multiply the coefficients first. 3 times 5 is 15. And then under this radical, we have an 8. Under this radical, we have a 50. Multiply those two together, you should get 400. Now, 400's kind of large, but that one's kind of obvious, right? What's the square root of 400? 20. So we're going to have 15 times 20. Multiply those two together, and the answer is 300. Jumping down to number 21, I'm actually going to do the opposite of what I did up in number 14. Number 14, I separated them. Number 21, I'm going to put them both under the same radical. I'm going to say the square root of 112 over 4. You can go either direction, just depending on the problem, whatever is going to work. Why did I do that? Because I can tell that 112 is evenly divisible by 4. 4 goes in there 28 times. So this is equal to the square root of 28. And so I look at all the perfect square factors that are less than 28. I've got a 25. That's definitely not a factor. I've got a 16, not. 9, not. But how about 4? Yep, 4 is a factor. So we're going to say the square root of 4 times the square root of 7, which gets me 2 rad 7. I'm just going to take a guess that 120 is divisible by 15. Plug it in the calculator. And yes, it is. It's 8. So I'm going to say this is equal to 6 rad 8. And numbers less than 8 are 4 and 1, so definitely 4 is a factor, a perfect square factor. So I'm going to have 6 times the square root of 4 times the square root of 2. And the square root of 4 is 2, so this is 6 times 2, rad 2. So an answer ends up being 12 rad 2. And that works out real nice. Any questions on 12 through 22? Because those are all really similar. And number 23 is going to get into something a little different. Okay? Why? Because there aren't any perfect square factors of 3, and there aren't any perfect square factors of 8, and 8 definitely doesn't go into 3 evenly. So I'm kind of stuck, right? So we need to do something called rationalizing the denominator. So you've probably heard of rationalizing the denominator before, but it may have been a while. Probably like 7th or 8th grade, right? That you probably did that. So the way it works is you're going to take the denominator, which is the square root of 8, and you're going to multiply by the square root of 8 over the square root of 8. And the point is to get the radical or the square root out of that denominator, okay? So we purposely multiplied by the denominator to get us a perfect square. Because when you multiply the square root of 8 times the square root of 8, you get the square root of 64. And that one's a perfect square. If you don't end up with a perfect square down there, you did something wrong, go back and fix it. In the numerator, you've got square root of 24. All right, so let's simplify. Denominator is easy. Square root of 64 is 8. Numerator, we have the square root of 24. So we look for, let me shrink it again. We look for any factors that might be factors of 24. 24, and the only one I see is 4. So I'm going to rewrite it as the square root of 4 times the square root of 6. And I know the square root of 4 is 2. And I realize, oh, I could also reduce here. 2 goes into 2 once. 2 goes into 8 4 times. So this reduces to square root of 6 over 4. And that's how you rationalize a denominator. We don't have a whole lot of questions like that, but it's good for you guys to see that. Okay? 24 is going to seem easy after rationalizing the denominator because these are what we call like terms. We have the same number under the radical here and here. So we can write a 1 out front of each. 1 rad 10 plus 1 rad 10 is just 2 rad 10. Sometimes you can simplify that a little bit more, but square root of 10 you can't. Okay? 25 is asking us to add these as well, but we don't have the same number under the radical. So let's simplify it first and then see if we end up with the same number under the radical, which means we probably will, right? So the factors of 50 obviously going to be 25, right? So I'm going to rewrite this as 3 times the square root of 25 times the square root of 2 plus, and then 98's a little bit trickier, right? So you look at the perfect square factors that we wrote over on the side. Anybody see which one it is? 49. So we're going to say the square root of 49 times the square root of 2. So we're going to have 3 times 5, square root of 2, plus 7, square root of 2. 3 times 5 is 15, so we have 15 rad 2 plus 7 rad 2. Now we have like terms. Like terms just means you're going to have that same number under the radical here and here, so they can combine together. We take their coefficients, the 15 and the 7. That gets us 22. 22 of them. So you're trying to get the same like terms if you can. And usually there is something to combine. Otherwise, they're not going to give you that problem. All right. Number 26. We have a 63 under the radical. Anybody recognize what the perfect square factor is? Think of the factors of 63. 9 and 7. So we're going to rewrite this as the square root of 9 times the square root of 7. And then the second term, anybody recognize a perfect square factor of 20?
5 and 4.
4 and 5, right? So we're going to say square root of 4, square root of 5, minus, and then square root of 7 doesn't have any factors at all, so just leave it. Square root of 9 is obviously 3, so we have 3 rad 7. Square root of 4 is 2. 2 times 4 is 8, so this one's 8 rad 5. Minus the square root of 7. So it would be nice if they were all like terms, but only the first one and the last one are. Everybody see why it's only the first one and the last one? Okay, so we're going to do 3 rad 7 minus 1 rad 7. I'm going to squeeze a 1 in there, which makes it 2 rad 7. And then this guy, we don't add or subtract anything because it doesn't have a like term, so it's 8 rad 5. Have to keep them separate. Okay? Last row is just asking for cube roots. Okay? And some of them are pretty obvious, like this first one. What number times itself is going to get us to 8? 2. So if you have the third root of 2 times 2 times 2, the answer is 2. I think the second one's, or the middle one's easy too. Anybody see that one? 5. So the third root of 5 times 5 times 5 is just 5. And the last one, the numerator looks easy, so let's rewrite it as the third root of 27 over the third root of 512. Numerator's easy. Denominator, I have no idea, right? So third root of, what is the third root of 27? So I'm going to write 3 times 3 times 3. And then, does anybody happen to know what the third root of 512 is?
8.
Yeah, it is. But let's say we didn't know, okay? So I'm going to show you in the calculator how to do it. Did you really know? Or did you do it on your calculator? Oh, okay. So let me show you how to do it on your calculator. So you got, you're going to type in a 3 because you want the third root. And then you're going to use the button that says the X root. So when you type it in, make sure it says an X right here. Otherwise, it's just going to take the square root. And then you type in 512. Because you don't need a parentheses. Hit enter. Sorry, I had a parenthesis in there. Delete. Oh. Okay, there it goes. And it gives you the 8. So this is the third root of 8 times 8 times 8. So this simplifies to 3 over 8. All right.